Quick sort of recap from Friday. We talked about solving quadratic equations. So taking a quadratic thing, setting it equal to, some number, right? So we know how to deal with quadratic functions. Basically, now we're asking like, when is a given quadratic function, equal to some y value, right? For what x's does it, reach some height or level if you want. One way that we can think of that is sort of graphically finding, well, let's, let me put maybe an example, just kind of generic thing. If I'm trying to solve something like x squared plus bx plus c equals 0, there we go. Graphically, that would mean finding x-intercepts, or again, we'll also call those zeros of the function y equals ax squared plus bx plus c. Because if we're looking at this as a function, then setting it equal to 0 means figuring out where these points happen, right? Thinking about the left-hand side, the quadratic part of this as a function, then you're also thinking of the right-hand side, 0 as a function. Y equals 0 is just the x-axis. So graphically, that's kind of what the interpretation is. Actual methods that we can use to solve, we've got the quadratic formula, which again works every time for something like, again, this, I'm just going to put it here again for emphasis. If we're trying to solve that, then x is negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So you peel the coefficients off, you mush them together the right way, and as if by magic, it gives you solutions. Again, this is a provable thing. You can derive this formula. The plus or minus means that there are 2 things there, right? 1 plus and 1 minus, right? So there are 2 solutions there, unless that square root thing ends up being 0. And just be careful with all the arithmetic, right? Because forward operations stuff for sure comes into play. Probably you want to take things kind of, 1 step at a time. Don't try to get too much sort of all at once. That's when you tend to make mistakes. Like I would do, probably the b squared and the 4ac and the 2a, like do those multiplications, then do the stuff under the square root, then start simplifying, do the division last. Once you do a couple, you get a feel for it. It's, not a huge deal. Works every time, but it's always, 4 or 5 steps of simplifying. Other stuff, factoring. If we can factor and apply I made a big deal about this Friday, I'm going to continue to do so, zero product property, right? So factoring is only helpful if you're factoring a thing that's equal to 0. So for example, I think the one we did on Friday was something like this. We figured out that factoring the left-hand side looks like that. Because this is equal to 0, we can apply that 0 product property. Split the factors up. Because the only way you can multiply things and get 0 is if one of them was 0. And then just solve the individual smaller linear equations, you get -2 and -3, which are the solutions to that. Right, so again, nice when it works, but one, we got to keep the equal to 0 thing in mind because that part's really, really important. And two, factoring in general is, not the easiest thing. So there's that. Okay, and then the other thing that we talked about was the idea of using a square root. If we have a perfect square, we can take a square root. But when we do that, we have to introduce a plus or minus. Because reasons, really, the reason is, goes back to x squared not being 1 to 1, right? So when you sort of turn the thing on its side, it's not a function anymore, which is where you get a positive square root and a negative square root that, sort of make up that like sideways parabola, right? So for example, if x minus 2 squared is equal to 16, maybe. No, let's make that 20. The thing I'm looking at here is that the left-hand side is a perfect square, right? That's the part that matters. So because the left-hand side is a perfect square, if I take a square root, those are going to cancel, right? Left-hand side would just be x minus 2. Now, really, when you take a square root like that, what you get is actually the absolute value of the stuff inside. But what that means is that we get a plus or minus. If you want to actually write out the absolute value, like if that part helps you, then go for it. I'm assuming that it might just kind of throw some people off. I'll write it this one time, but which means that x minus 2 is plus or minus the square root of 20. So x is 2 plus or minus square root of 20, and 20 is 4 and 5. So it's 2 square roots of 5. So those would be the 1 plus and 2 minus, right? 2 plus 2 root 5 and 2 minus 2 root 5. Those would be the two solutions to that quadratic. They're not particularly, pretty, like we've got this irrational square root of 5 in there, but like that's okay. That's the solution. Those are the solutions to that equation. Okay, so that's when that square root thing comes in. If you've got a perfect square, you can do that. If not, then not so much. So it's kind of a specialized thing. It's nice when it works, but it doesn't work all the time. Okay. All right, that's pretty much where we're at. That's what we know. I asked you to go do some problems over the weekend. I hope you did, but even if you didn't, let's take 10 minutes or something. You guys give these in 1 through 4 a shot. As usual, talk to your group, ask questions if you have some.
So C is just 0.
Yeah, for quadratic formula stuff, if something doesn't show up, like either B or C, A has to be there or it's not really quadratic. If B or C don't show up, you just treat them like they're 0. Yeah. So split up the plus or minus now. And then add, I would add first. You can divide, but you have to make sure to divide like both places. So I would add first, treat the top as though it's in parentheses. Yeah. -2. Yep. Good. Yeah, I think that one is like just reduce the bracket. Yeah, but, yeah. Right. Yeah. Yeah. So for the most part, we're going to want exact answers. So if it's a fraction, reduce the fraction rather than decimal. If there's a, well, like that one we just did a second ago with a square root, if there's some kind of square root, like simplify that, but don't go with the decimal most of the time. Yeah, okay. Right. If you can use it, yeah. Right. Yeah. Yeah. Yeah, and actually it looks different, so that's always a thing. But actually, the factoring is easier because anytime you're factoring, the first thing you want to look for is common factors, like anything you can take out of everything. Right. So what are those factors? Yeah. So to factor that out, to the left, then you have factored and split up. Okay. So that part is important. So you gotta do that first, but yeah, p would be negative, so e squared. So like before you can factor, before you can quadratic formula, you need everything on one side of the equation. So the first thing you have to do is 21, subtract from both sides. I don't think it's factoring the quadratic formula. Both are up to 0. Inside. So first I have to multiply it out. And multiply it out. What is that? Yes. Probably big set of parentheses. Type all the stuff in divided by another set of parentheses. Or do like small. Some of the newer ones give you a fraction bar like that. Just do like parentheses, type in all the stuff on top, close it, and then divide it by. Okay. Four times A times C should be fine. Yeah. Right now it's yeah, basically you want I don't know if I all right, y'all tell me about 3 real quick.
What do we need to do first? Subtract 21. Whether we're going to try to factor or use quadratic formula, we need that first, right?
Factoring or neither factoring nor quadratic formula apply unless we've got everything on one side of the equation. So subtract 21 first.
Now what? Yeah, that actually does factor because 6 and 4 would work, but I get that, probably this would be a place where you just jump to the quadratic formula. I said something on Friday about this, I think, but factoring, I would say, like, if you can, look at it and see kind of right away, like, oh, I know how that should factor and check and work. That's great. If not, there's not really any point in spending a lot of time trying to, sort of make it. All right, so you want to use quadratic formula? Let's do it. Negative b, so the opposite of b would be 2, plus or minus the square root of b squared minus 4ac over 2a. Again, just, one more time, my advice, write down the setup for the quadratic formula. Don't go straight to calculator, because if you do and something goes wrong, I can't figure out where you went wrong. 4 times 24, 96. 96. And it's minus 4 times negative 24, so plus 96. So 2 plus or minus 10 over 2. Now at this point, for simplifying, I would split up into the positive and the negative version of that. 12 over 2, negative 8 over 2, so 6 and negative 4. As much of that on the screen as I can. There you go. So 6 and negative 4. Everybody okay with that? Everybody agree? Anybody have any questions? Once you've, sort of done a couple and start to get a feel for it, you can, shorten or combine a couple of those arithmetic steps probably. I would, again, caution you against, doing too much at once, because that's when trouble happens. But there you go. All right. So take a look now at the kind of bottom half of the first page there where we're talking about graphing. Graph that function. All right, x squared minus 2x minus 3. So what do you know about it right away? Before we even had a graph to look at. Quadratic, so it's a parabola and it opens up, right? Because the leading term is positive. Okay, so it opens up. Now that I've got the graph to look at, what else do we find out? Well, we learned about some specific stuff, right? It's got x-intercepts at -1 and 3. There's a y-intercept there. There's a vertex there. Those are all maybe significant or important for their own reasons. Thing I asked you about here is, where does x squared minus 2x minus 3 equal 0? -3. Where does the function equal 0? Look at the question, right? Where does x squared minus 2x minus 3 equal 0? Your answer to that would be x's, right? Okay, so what are we looking for? -1 and 3, right? The x-intercepts. Okay. Well, try solving that by hand. Solve it anytime I say analytically, that just means by hand. Quadratic formula or factoring or whatever. X squared minus 2x minus 3. That factors, or you can do quadratic formula, but either way, we get 3 and -1 as solutions, right? Which again, were the same as the x-intercepts. X equals 3, x equals -1, were the x-intercepts of the function y equals x squared minus 2x minus 3. Okay, so again, kind of tying these ideas together, thinking of this as a function, setting it equal to 0 means find the x-intercepts, right? So solving this equation is going to tell me where those happen, right? Which is why we get the same things for those two, sort of different wordings of the same question. Okay. Well, what about y equals x squared plus 1? Again, it's a parabola. Leading coefficient's positive, so it's opening up, right? It looks like that. If you want, you can think about this one in transformation terms if you want. X squared plus 1, that just moves it up 1, right? Okay, so y equals x squared plus 1. If I try to set that equal to 0, what's the problem? Well, it doesn't have any x-intercepts, right? Does that cross the x-axis anywhere? No. It sits above the x-axis. The lowest point is 1. So setting it equal to 0, there are going to be no solution, right? Because it's opening up and away from the x-axis. Okay, so we know that this has no x-intercepts. Well, how can I see that from the equation? X squared plus 1 equals 0. Because again, that's asking the same thing. That's where does x squared plus 1 as a function equal 0? Where's it across the x-axis? Well, it doesn't, right? How might we try to solve that? Same way, right? Let's try quadratic formula. What are A, B, and C here? 1, 0, and 1. All right, so negative b plus or minus square root of b squared minus 4ac over 2a. I don't really need to write that 0 anymore, do I? You see the problem? What is it? What's the square root of -4? Try to calculate. See what it says. Square root of -4. Just gives you an error. What's it gives you? Ooh. Wait, what? All right. So it might give you some kind of error, might tell you something about it being non-real, might give you something involving an I, right? The square root of -4, the number that when you square it gives you -4. Well, when you square real numbers, you get back something that's positive, right? Or non-negative anyway, it could be 0. This though is weird. right? It's not a real number. So to deal with things like this that don't have any real x-intercepts and don't have any real solutions, we have to introduce imaginary or complex numbers. So to deal with things like the square root of a negative number, we introduce what we call the imaginary unit, I, which is the square root of -1, right? So unit just means it acts like 1, right? 1 is the unit in the real numbers. I is the square root of -1. That means if you square I, what do you get? What happens when you square root? They, undo each other and they cancel. Yeah. So I squared is -1. All right. So we're kind of, taking things and we're moving to sort of a different sense of dealing with numbers, right? Complex numbers, imaginary numbers work differently than real numbers. So a lot of the stuff that we're used to, like not being able to take the square root of a negative or squaring something and always getting back something that's non-negative, right? Getting back a positive or maybe 0. All that is kind of out the window when we start talking about complex or imaginary numbers because they work differently, right? They're explicitly to deal with stuff like this, right? To deal with negatives under a root or squaring a thing and getting a negative. So the way these work is that the like standard form for a complex number A plus BI. A is called the real part. BI is called the imaginary part. A and B are just some, coefficients, some parameter like they normally are. The I though, that's that imaginary unit, right? So basically the way you think of this is that, something like 2 plus 3i has real part 2 and imaginary part 3i. What we're going to look at is how we do arithmetic with complex numbers. And then, of course, the real kind of motivation is for how these come up in solving stuff like quadratics. So here are some square roots that have negatives in the radicand. Take a minute, think about how you would simplify those. Square root of -16, square root of -20. If I is the square root of -1, how should we simplify those? All right, so what's the square root of 16? 4. What's the square root of -16? I times 4. Or normally we write that 4i. So the idea is just like usual, you think about factors of that number, right? If you want, you can even break it down using the same kind of factorization you would use to like simplify a root. -16 is -1 times 16, right? Well, the square root of -1 is I, and the square root of 16 is 4. So basically, if there's a negative under a square root, like if you have a negative radicand, then what that means is that there's a factor of I there. Yeah. So the square root of -20, that would be the same thing as I times whatever the square root of 20 is, right? So how do you simplify the square root of 20? Two square roots of 5, yeah. So 2 square roots of 5 times I. Or 2I root 5 or whatever. 2 root 5 is the real part of that, then I is the imaginary part. Okay, what about -50? Negative under a square root, so sort of comes out as an I. And then just work on simplifying the square root of 50. So what are some factors of 50? 10 and 5. And factors of 10 are 5 and 2. So how do we break up the square root of 50? 5 square root of 2, right? Because it's 5 times 5 times 2. Anything that shows up twice because it's a square root can come out. So 5 times the square root of 2. It's over here maybe. So we've got I squared times 5 square roots of 2. But what's I squared? What is I? I is the square root of -1, so I squared is -1. Okay, so stuff that we're going to be sort of looking for in simplifying stuff that maybe involves imaginary complex numbers. We don't want to leave negatives under roots. So if there's a negative under a root, that means you can factor out an I out of the radical. And we don't want to leave powers of I that are bigger than 1, right? So like I can have a factor of I don't want to leave an I squared because I can simplify an I squared, right? I squared is -1. I cubed would be I squared times I, right? So it's negative I. You'll again get to sort of fiddle with that in the homework a little bit and get a feel for it. But basically any power of I other than 1 we can reduce to something else, right? By just thinking about what's happening there. Okay. Other complex arithmetic stuff, the way that you add and subtract and multiply complex numbers is exactly the way that you would do it if it were an X or a T or anything else instead. The only difference is that, well, this kind of thing that we just looked at if we end up with some higher, power of I, we can simplify it down. So if I'm going to like add complex numbers or subtract complex numbers, you just do it the same way you would if these were x's instead of i's, right? You treat it like terms. So 2 plus 3i, this is 1 complex number plus another one, 4 minus I. The way I would add those together is just add the like terms. So what are like terms here? 4, and then 3i and negative I, right? So you can just add the real parts and add the imaginary parts. So what would that give you to here? 6 plus 2i. That's it. Subtraction would work the same way. So just think about it as, combining like terms. We add the real parts to get 6. We add the imaginary parts to get 2i. Multiplication would basically be the same idea. So here I would need to treat this like I'm foiling. The only difference is going to be that if we have things that we can simplify later after we've done it, we go ahead and do that too. So if you multiply those out, what do you get? Negative 2 times 4. The outer negative 2 times negative 2i, so plus 4i. The inner part of the product would be plus 12i. And then the last part would be minus 6i squared. Okay. What can we do to clean that up a little bit? Add the 4 and 12. What else? I squared is negative 1. So this is the same thing as negative 1. That means I can rewrite this as negative 8 plus 16i minus 6 times negative 1. So actually that I squared term isn't imaginary at all. It's a real number. It's just, sort of disguised. By the way, I'm using kind of a, scripty I. Just do something to make sure that you can tell that your eyes are eyes, right? Well, and that I can tell that your eyes are eyes. Whatever that looks like for you. Okay, so the actual multiplication part is exactly what we would do if it was an x instead, right? This part, combining those middle terms, right? 4i plus 12i. That's exactly what we would do if it was an x instead. The only place that we do anything differently is that I squared, well, because of what I is, because of how it works, I squared, we can simplify a little bit further to negative 1, which means that this is actually not negative, but plus 6. It's actually a real number. We can then combine that with the real number sitting out front. Okay. Now division is the place where things get a little bit weird. Because what this says is 6, the number 6, right? A handful of 6 things, right? 6 is a real number. That's a thing I can make sense of. I know how to count. I know how to treat, especially a positive natural number like that. 6 divided by, well, division we usually think of as equal sharing, right? Or at least that's a good place to start.
6 divided by 2 plus 3i. That's where things get weird, right? We just introduced this imaginary unit. Now we've got this complex number, 2 plus 3i. And now some guy wants you to divide by it. That's weird, right? Because how on earth do I make sense of dividing by a complex number? Even the name makes it sound like it's, hard to deal with. Complex numbers, right? So the way we do this is that instead of dividing by a complex number, we say, okay, well, what I would really like to not have to do is divide by that complex number, but I know how to divide by a real number, right? I know how to divide by 4. That just means I split everything up equally with myself and 3 friends, right? So what we do is take this thing and rewrite it so that instead of dividing by a complex number, we sort of move the complex part, the part that has an I in it, we move that out of the denominator up to the numerator, right? So what I do is figure out a way to, sort of get an equivalent version of this where the I is not in the bottom, but only shows up in the top. The way we do that is to multiply by a thing that we call the complex conjugate. I'm just going to write it and do it, and then we'll talk about like why it does what it does. So I'm rewriting a fraction. So just like if you're doing a common denominator kind of thing, right? Like changing what kind of fraction it is, that's what we're doing. The thing I'm going to multiply by on top and bottom so that I don't change anything is 2 minus 3i. Again, I'm going to do that on top and bottom because all I'm doing is rewriting this fraction as a different but equivalent thing, right? So just like if you were going to do a complex or a common denominator somewhere to rewrite a fraction, same idea. Multiplying it on top and bottom means I'm really multiplying by 1, so I'm not changing anything. All right, then do the multiplication. Treat everything like it's in parentheses or grouped. So on top, 6 times the quantity, 2 minus 3i would be 12 minus 18i. And then in the bottom, 2 plus 3i times 2 minus 3i, FOIL or distribute everybody. 4 minus 2 times 3, so 6i plus 6i minus 9i squared. Is that anybody thinking something along the lines of, but that looks worse? That'd be fair. It does, right? There's a lot more stuff to write down than the thing we started with, right? It looks worse. What I want you to do for tomorrow, clean this up. So just like we just did on the multiplication problem before, clean stuff up here, see what you end up with, and then you'll see why what we just did was actually productive. Then, well, really anything else that we didn't, whatever else we didn't do on page 2, right? So for tomorrow, finish page 2, work through everything else that's there. Just give it a shot. We'll pick up there tomorrow, talk about one of those for a minute, and then move on. All right, y'all have a good day. I'll see you tomorrow.